Everyone, thank you for having me here. So during this presentation, I will try to introduce some of the new things that we have in the workings and to explain why Oraclize works in the way it does. So let's start by saying that Oraclize is a system which is blockchain agnostic. So we started 2 years ago, 1 year and a half, with integration with Ethereum, and most of our clients at the moment are using the service in the Ethereum context. But we think that our service, our engine, provides a value to a broader space, so even to other blockchains and even to applications which are not in the blockchain space. So as you can see here, essentially we stay in between web APIs, so any provider of data that you have already on the internet, and blockchain. So what we do is providing an Oracle service, but without being the data source. So we want to keep the two things separated. So we don't think that the data sources should start to integrate with the blockchain. There are many reasons for that, so I try to list some of the approaches that, in our opinion, are really bad ones. So essentially, first of all, we don't think that the data sources, so the providers of data, think about any web API, maybe, let's pick one, for example, let's say Wolfram Alpha, but it could be any others of your choice. So we don't think that these data sources should install on their own system blockchain adapters, because they don't really care about Ethereum or the Ethereum Classic fork, or maybe the DAO. I mean, it's not their job. So their job is just to provide data, right? And they are already exposing in a very standard way, which is the internet via web APIs, their data. So we don't really want to move all the complexity of the integration with the blockchain to their side, as upgrading that logic in case of any issue we could arise will be very complicated, right? Something else which we don't want is having any single dApp on Ethereum, for example, to run their own dedicated Oracle. That will be a nightmare as well. So think about providing a reliable system, or having each of you, all the developers, to start running a dedicated server for their own dApp with dedicated trusted computing techniques or other devices that they should buy with initial huge investment and so on. So we don't think that this is a good approach. And we don't even think that a service which serves the whole network, like Oraclize, should say anything around the quality of data, because it's not our job. So we just want to prove that the data is authentic. So authentic means that the data we report to the blockchain is the same that we got from the data source you want. So you choose what is a reliable, a trusted data sources, and then we just provide, if you want, the data transport layer, right? So often we have clients coming to us saying, okay, so which data source should I use for finding information around flight delays? Well, again, it's not a good choice. It's not a good approach just to come to us and ask, because there are really many different providers of data, and it should be at the end a choice of the developers and the users to understand whatever trust lines they want to open. So if you think about something simple like a price feed, it has an easy solution, which is, for example, to go to different data sources. So think about Kraken, Poloniex, and so on. Try to integrate with many and just do an on-chain average. So doing it on-chain is very expensive, right? So we spend a lot of gas. But I think that the reason why we are here is not because the blockchain is cheap. The blockchain was never supposed to be cheap. The blockchain is supposed to be safe. And if we do the aggregation off-chain, then we lose most of the transparency. So it doesn't make much sense. So this is the way Oraclize works. You have some contracts on-chain. So let's say a contract on Ethereum, which goes out to Oraclize. So it sends a query specifying a data source and a query. So it could say something like, I want to use Kraken, and this is the exact API call I want to do. And then Oraclize will fetch the data from the data source and send back a transaction to the contract with the actual result. With this system, since September 2015, we have sent pretty much 1.5% of all Ethereum public transactions ever, which is 180,000 transactions. And it's pretty much the most widely used Oracle service in a public context. It's pretty complex to understand if this is the case even in a private context, because there are not figures. But we have a lot of integration even with private blockchains. So we have different clients, both financial ones and startups, which are integrating with Oraclize even in that context. So it's on-demand data, so it means that we don't keep sending useless transactions to the blockchain and hope that somebody will use them. But we send the data just when there is a real need for a contract to use this data. Along with the result, we send the authenticity proofs. So this is what we have been doing for the last 2 years, so researching ways to prove to a third party that the data coming from a data source has not been tampered with while being sent to the blockchain or to a different context. This is very important because the data sources you want to get data from don't really provide signatures all in the same way, right? So we don't have them providing AC, DSA signatures that we can verify on chain. Some of them do, some of them will, but the number of data sources which is available on the internet is just huge. Pretty much any website serving data is also exposing APIs. So we don't want to having them to adapt to the blockchain. And this is why using techniques like those could help to leverage their data today while having strong security guarantees. So the way we do it, I don't want to go into details because I think I already did at EDCON 2. So it will be pretty much the same presentation. But the techniques that we are leveraging other than TLS Notary are techniques that we invented and which are based on technologies like Qualcomm TE, Samsung Knox. Everybody keeps talking about Intel SGX, but let me say it again. Intel SGX is really cool on paper, but the production keys are not there yet. So we are experimenting with Intel SGX. It's 1 year that all our infrastructure has servers which are SGX enabled, but we will not provide it to production until the production keys are available. So Intel SGX is not safe. One day probably it will, but it's all up to Intel to actually release the production keys. So it's not our choice, and we can just stand up and wait. Of course, you could ask data sources to adapt to the blockchain and just to provide custom schemas to claim that they are interested to integrate with the blockchain and the way they want to do so. Or you could ask them to provide custom signatures and so on. But again, this is a bad approach and this is not what we want to do. So instead, there are people which are probably smarter than us, which are trying to solve this problem in a broader sense. So the IETF has a draft which is being discussed since 2013, which is essentially a way to standardize the signatures that data sources print out in the header, they send back in the response. So essentially you can have a very generic signature included in the header, and you can ask data sources to adapt, as this is not blockchain specific. And even if this is not you, even if it's not you going to them and us, they eventually will, as this standard is being adopted already. So there is already a number of data sources which are providing signatures in the HTTP header of the response of the actual content that they send back. So this is very useful, and it can be used at some point to get even a stronger guarantee of the authenticity of data with no need to rely on attestators like we are doing with the different authenticity proofs that we have seen. So actually, Oraclize is integrating with this standard already. And the way you would use it is very simple. So you just change one line, and you change the authenticity proof. And instead of specifying TLS Notary or Android proof or the other authenticity proof that you have designed, you can just specify proof type native, which means that the data source is sending out a signature. And you want that the contract, you want the contract to receive this signature in the proof field so that then it can verify it. So this is very cheap to verify on chain. This is not blockchain specific. This is being adopted by different data sources, providers of web APIs already, and this is very standard. I mean, I know that the blockchain space is cool because we have a lot of ideas, but we don't really have to reinvent the wheel every time. So in this case, it's really not applicable because somebody else is working on the same very issue since 2013, and they have been iterating again and again to provide a standard way to do so. So again, we don't need the data sources to adapt, but we can still prove the authenticity of data in a trustless way if the only trust line we want to keep open is, of course, the one with the data source. There is no way actually to get rid of this trust line because, Oraclize or you, we cannot go back and check if the sensors are broken of the one providing the data for temperature or things like that. So there is no way other than relying on more parties and, so in a nutshell, these are some of the main features that Oraclize is providing. So essentially we enable any data source to interact with smart contracts with no need for them to even know, with no need for them to integrate with the blockchain, and with no need for you to ask the permission to anybody. You can schedule transactions for a future time, so this is being used quite heavily actually by smart contracts so that they can call themselves again and again, and you can have some kind of autonomous system in the sense that you don't have to set up your own server to trigger your smart contract every hour or once per day. So you can ask Oraclize to send back the callback transaction after some time. And this opens to quite few interesting use cases. Of course, it will be much safer to use something like the alarm clock for that single specific feature. But I think that nobody's keeping up the alarm clock service at the moment. So this is a good way to actually have the same feature in a simpler way, and you can verify, of course, if Oraclize sends the transaction too early by looking at the block timestamp or things like that. So another thing that I don't have the time to go into the details, but it's very interesting and it's very recent, is the off-chain auditable computation. So this is something that 2 days ago was discussed quite in deep at a pre-conference event. So there was a panel around computation above and beyond the blockchain organized by asset. And we have seen different approaches. So we have seen iExact, Golem, decentralized court, and the Oraclize auditable computation. So they all solve slightly different issues. Just briefly, the way the off-chain auditable computation works is you define a piece of code, you send it to IPFS, and your smart contract will call Oraclize specifying as data source computation and as query the hash of your code. So what happens then is that Oraclize will create a new instance in a cloud environment of a throwaway virtual machine. It will execute your code. It needs to terminate and to be stateless so it needs to terminate within 10 minutes, something like that. And we send back the result to the blockchain along with the authenticity proof. So what does the authenticity proof prove this time? It proves that the instance, the throwaway instance, was actually initiated in a way which is fully locked down. So it proves that Oraclize didn't have access to the virtual machine, and that context is safe if you trust the attestator. So the attestator in that case is Amazon Web Service, but of course you could potentially integrate it with others, and you could lower the trust by running it on many different cloud providers and then checking the result. So this is interesting for many specific applications which you cannot decentralize because, for example, they are not deterministic. So think about executing a random number, like generating a random number. Or maybe if you want to calculate, we are using this with some banks to calculate the pricing engine of derivatives, because you cannot have floating point arithmetics in a centralized system today. It's explicitly disabled in the EVM and even in EWASM, as we have seen. So if you want to execute something like that, of course you don't have the limitations of decentralized systems, which is cool because it enables some kind of applications which today are not viable in a fully decentralized way. So then it's up to you and to your application to understand if you are willing to open that trust line or not. So it's specific on the application. In some cases it makes sense, and it also enables some levels of privacy and so on. It can also be used to integrate with the traditional financial payment system, because you can have like a very generic piece of code that you define, which interacts with the APIs of any payment API. So you can detect a payment, and you can maybe send back a transaction to your contract so that fiat-backed tokens can be issued on your side. So it's very flexible. You can pretty much execute anything, and there are not many restrictions. Again, this is executed once, but the authenticity proof enables the verification that the result is coming from the hash of the code you have specified, and you can verify it at any time, at any later time. Also, we have novel integrations with, IPFS was already there, so you can actually retrieve some content from IPFS straight from your Solidity code if it makes sense for your application. Of course, you have to be aware for the size, but there are some ways you can get just a very small piece of the data, which is maybe the one you are interested in. We have integration even with Swarm. It's experimental, of course, but it works, so you can test it out. So you can just write Swarm as data source, and as query, you can specify the actual hash of the content you want, and Oraclize will try to get the result and send it to the contract. As for those data sources, it's not trivial to get the authenticity proofs, because the authenticity proofs just work with HTTPS requests, while in this case it's a different protocol. But we are working hard to understand which kind of proofs we can provide in that context. So for example, in Swarm, it will be probably quite easy by leveraging the seaboard decoding functions that we are implementing already for some internal contracts we have. So actually, you can verify if a given piece of code in a given chunk in Swarm is really part of the data, of the root of the data that you have asked for. Well, there is no need to install anything to get started with Oraclize if you didn't already. And it's integrated on the mainnet, on the public testnet, of course. And even with browser Solidity, so there is a link on the bottom, I think you can see it. And this is a fork of browser Solidity, which includes the first probably plugin for browser Solidity. So essentially it's a new tab on the right side of browser Solidity, so that you can test in memory the execution of an Oraclize-based contract. It works even on private chains, so if you download from our GitHub the Ethereum bridge tool, you can use it from any private chain, even with TestRPC, with Truffle. It's integrated with even with Ethereum Studio IDE, with Ethercamp, blah, blah. So essentially, there is no need to install anything unless you want to. And if you want, well, a couple of weeks ago, I guess, the first implementations of the EAP 190 was out, which is the Ethereum package management, which is a way people will start distributing libraries. And this is being integrated, well, this is integrated already with Truffle and Populous, for example. So now if you really want to install something, you can write one line of code like Truffle install Oraclize. So from what I've seen, our library is actually the first library on the package management, which is not there for testing purposes only. So you can write Truffle install Oraclize and use it straight away. Thank you. I think I have still a couple of minutes for questions, if there is any. Yep.
Is there any way to have a hashing mechanism so that if someone requests some information in the last 5 minutes, I can split the cost of the transaction with them?
Well, I think, it's not something we provide on the Oraclize side at the moment, because it's the first thing we are being asked for something like this. But I think this is something which can be easily delegated to a smart contract that the community does manage if there is really a need for that. So for example, you could have an external contract which goes out to Oraclize and keeps in storage a copy of the most recent answer. But of course, it depends on the use case. So think about asking for a random number. You don't really want to use the cached version, right?
Yep. Did you consider to send something confidential? Outside, like I know the doctor can send data encrypted on Oraclize public key and you decrypt the blockchain and send it properly.
It's already something we provide since 1 year now. So if you look in our documentation, there is a way to do exactly that. So this is even one reason why you don't want to distribute or fully decentralize something like that. So one reason is that I don't think many of you are willing to spend thousands of euros to set up custom trusted computing devices in a distributed fashion to guarantee high availability and blah, blah. But another reason is that in some cases you really want confidentiality. For example, if you call out to a payment API, you have some secret credentials, right? So you cannot disclose them to the whole network. And you can encrypt either the full query so that nobody can see the query. For example, you could have as data source Vitalik, and as query, you can have an encrypted human readable query for him. So this means that just him and Oraclize will be able to see it. And this opens to some interesting use cases. So think about using even mechanical Turk and things like that. If you use the nested data source, you can also encrypt just part of the queries. So for example, there are some quite complicated contracts like VDICE or the flight delay DAP that Eterisk guys that are here did, which are using the nested queries. So essentially, you can encrypt just a very specific part of the query so that you still have the transparency for the data you're asking for, but you can just hide the credentials.